Pedgies Corner, we're going to continue working with solving linear systems of equations, but we're going to look at some word problems today. So students often have problems with word problems. They panic, they get overwhelmed, they look at and see all the words in math, and they just kind of have a negative attitude. I really like to go through the word problems and just kind of take a relaxed approach. I'm going to read it through once. I'm going to understand it. I'm going to pull things out that I need. So hopefully it's not so overwhelming. So let's look at the first one. It says, in one day, the National Civil Rights Museum in Memphis, Tennessee, admitted 321 adults and children and collected $1,590. The price of admission is $6 for an adult and $4 for a child. How many adults and how many children were admitted to the museum that day? So just kind of when I read through that first problem, I just kind of get an idea of what's going on. Okay, we're talking about the museum. The name of the museum and location does not seem to matter. We're talking about how many kids and adults went in, how much was collected, and obviously there's a different price for the two of them. So we're going to go from there. Now, one thing I also like to do, because looking back to the word problems, and you're going to have to reread sentences again and again, I like to do this, what do I know? Pull everything out that's important. 321 people were there. That's how much were collected. That's how much was collected. And it was $6 for an adult and $4 for a child. Now, also, it says how many adults and how many children were admitted. So that's my unknown. So that's what I need to do. And this is also where students kind of get confused, is they kind of forget what they're looking for, right? So I'm going to now you can use X and Y. I like to use the letter itself. It helps me a little bit at the end. Let A equal the number of adults, and let C equal the number of children that were admitted. Now I have two variables, so I'm going to need two equations to solve this. And I like to do, and looking what we're talking about here, in this particular problem, we're talking about how many, and we also have a money aspect of it too, right? So when we're looking at quantity, how many people were admitted? Well, the number of adults plus the number of children, we have over here, look, we already pulled it out, 321 people total. The same idea for money. It was $6 per an adult plus $4 for the children, and we had a total collection of $1,590. Now, at this point, you have done either substitution or elimination, so it doesn't matter which method you use. I always tell students, too, like if you're trying it one way and it's just not working, then try it the other method and see, whether you were just making a computational mistake or maybe your equations were set up incorrectly. So, in this one, I really do, I like to use elimination. I just think that it's easier. So, I'm going to take this first equation and I'm going to multiply it by -4. I'll rewrite it underneath. So I have -4a minus 4c is equal to -1284. And again, the idea was I want to get rid of this c variable, eliminate it, so it zeroes out. So I have 2a is equal to 306. So a is equal to 153. I go back to my other equation to find out the equation I work with already. And I have 153 plus C is equal to 321. So I know there were 168 children. So again, the bottom line says how many adults and how many children. So I don't want to leave it just as A and C or in a coordinate form. It's a word problem. I want words in my answers. So I have 153 adults. And I have 168 children. Now, again, you would go back on test day for sure and substitute these both into both equations to make sure it makes sense. All right, let's look at our next one. The next one we're talking about, this happens a lot, right? All our fundraisers that we do for activities or our sports that we have, music situations, and trying to raise some money. So it says your class is selling wrapping paper and candles for a fundraiser. Rolls of wrapping paper sell for $5 each. Candles sell for $4 each. A total of 526 items were sold, and then we're raising $2,327. So again, we see what's going on. We have a fundraiser. We're selling 2 items. They each have a different price. They tell us how many were sold, right? 526, and they tell us how much was raised. So again, I can say let W equal the number of wrapping paper sold, and then we're going to say let C equal the number of candles. Now let's take a look. Look, our bottom line was how many candles. So we're going to use, we obviously have to use W for wrapping paper, and we're going to have to solve for that, but candles is really the only thing we need to answer the question. I, again, have a quantity equation because I'm talking about how many, and I have a money equation. So wrapping paper and candles, there were 526. And then $5 per wrapping paper plus $4 for the candle. And we have $2,327. So again, we have in our quantity equation, how many. And our money equation, we have that's money, and that's money. So I know at least I used the right variables and the right quantities in the right spot. So again, I'm going to multiply this equation. I'll do it by -5. So that gives me -5W minus 5C is equal to -2630. I add them. My W's are eliminated, which is what I wanted. I have -C is equal to -303. So C is equal to 303. Now, I wanted to know how many candles sold, so I could stop there, but I don't like that. I really like to check. This is so easy to check, especially on a test. Substitute it back in, and I know that W is equal to 223. So I know that 223 plus 303 gives me 526. If you were, again, to substitute it back into your money equation, that would be another way to check to make sure that you're okay. So the bottom line is how many candles. So I say there are 303 candles. 303 candles were sold. Okay, let's look at our last problem for today. Now, this one's a little bit different. First of all, it's multiple choice. You see this a lot on standardized tests, and the setup's different. It says Samantha and Maria purchased flowers. Samantha purchased 5 roses for X dollars. So they tell us what X is actually there, and 4 daisies for Y dollars each, and spent 32 on flowers. Maria purchased 1 rose for X dollars and 6 daisies for Y dollars each, and she spent $22 versus the $32 that Maria spent. I'm sorry, that Samantha spent. So in our setup, first of all, we know from what was told is that X is the price per rose, not the quantity that we've seen in the last couple problems, and Y is the price per daisy. Now, in this time, they give us 2 equations. But it's not quantity and money, even though that's what we're talking about. One is about Samantha and one is about Maria. Samantha, right, if you go back, she had bought 5 roses and she bought 4 daisies and she spent $32. Maria only bought 1 rose, but she bought 6 daisies and she spent $22. So I'm looking at my statements and I have to figure out, there's kind of a lot of things going on. So first thing, again, I'm going to have to solve it. So I have 5x plus 4y is equal to 32. And then x plus 6y is equal to 22. I'm going to multiply that second equation by -5. I like, again, elimination is just a little quicker for me. I like that one a little bit better, but you can also solve this as elimination. That gives me -5x minus 30y is equal to -110. So I have -26 is equal to -7. So y is equal to 3. Substitute back in the other one. I'll save some time here. And x is equal to 4. Now, here's the thing. That's not how many were sold. That's the price, right? So we have y is $3. That's daisies. That's the price for a daisy. And $4 is the price for a rose. Okay, so we've solved it, but now we have to look at our multiple choice. Let's see what we have. I'm going to rewrite this up here so we can see. We have $3 for a daisy and $4 for a rose. So a rose costs $1 more than a daisy. Well, that's true. We're going to kind of keep that there. I don't like to ever just jump on the first one in case you made a mistake or you're like, wait a second, that seems like it's true as well. Or maybe the question is which one is false and not true. Let's look at letter B. Samantha spent over 4 times as much on daisies as she did on roses. So let's see if that's true. So Samantha She bought 5 roses. So 5 roses times 4 is $20. And her daisy, she bought, let's see, 4 daisies times $3, that's $12. So she did not spend 4 times more on daisies at all. So that one's not true. Okay. Letter C, Samantha spent $4 on each daisy. No, that's not true. She spent $3 on a daisy. Each rose was $4, right? And the last one, Samantha spent more on daisies than she did on roses. Well, let's even go back. No, that's not true either. She spent more on roses, right? That $20 more. So the answer is, in fact, letter A, which is what we thought originally. But again, always a good idea and a good habit to get into in a multiple choice to go through all 4. Okay, great job today. Have a good day.